Welcome to section 9.4, Systems of Quadratic Equations. Our focus is going to be on solving quadratic equations or systems, but we also want to make sure that we know how to identify each of these as well. So let's go ahead and take a look at these. We've talked about this throughout the conics sections, but let's go through and make sure that we understand how to identify which conic we're looking at. So the first thing is, to answer that first question is, how many square terms do we have? And if we only have one square term, which we do in the first two cases, then we know that these will be parabolas. Parabolas are the only ones that only have one squared term. So what's kind of the next step? Well, once you notice that there's two squared terms, such as this one, and really the rest of them, what's happening with the two square terms? Are they being added or are they being subtracted? Alright, and once you identify that, then the question is, okay, these are being added. What's true about their coefficients? Well, in this one, the coefficients are the same. On the next one, they're different. So on this one, we'd be talking about a circle, and then this one would be an ellipse. And then where the square terms are being subtracted, then we know we are talking about a hyperbola. And so that's how we're going to identify the different conics. I also have a flow chart kind of on the next slide where you can kind of read through and kind of answer a couple of questions as you're looking at these. And you know, how many variables are squared? That was that first question that I was asking on the last slide, is if there's only one squared term, then it's got to be a parabola. Okay, what happens if there's two squared terms? Well, we need to make sure everything's on the same side. Normally it is, but we need to make sure of that. And then also, what's that next one? How many squared terms do you have? And then are they positive or negative? So are both squared terms positive? Well, if they are, or if they're not, I guess, we can say that it's a hyperbola because you'll be subtracting those squared terms. If they are the same, then the question is, what are their coefficients? Are they the same? If they're the same, it's a circle. If they're not the same, then we're looking at an ellipse. And so once again, kind of just going through and being able to identify those different conics, because in the test you're not going to know. I'm not going to tell you which one you're looking at. You've got to be able to identify. Alright, on the next one, what we're going to do is get into the system one. And I'm going to first do this by graphing. Most likely we're going to do this using algebra next time in terms of using substitution and elimination. But this one I just want to kind of show you what it looks like to graph and then recall, you know, systems, what we're looking for. So let's take a look at the first equation, x squared plus 4y squared equals 36. Identify that it's adding two squared terms and the coefficients are different, so we're looking at an ellipse on this one. Try to write that again. We want to divide by 36. We get x squared over 36 plus y squared over 9 is equal to 1. It's supposed to be a 4 there. And so it's in standard form. Your vertex, or your center I should say, is at 0, 0. Your a squared is the largest at 36. B squared is 9. So we know a's distance is 6 and b's distance is 3. The center is located at the origin. Now we need to know whether this is horizontal or vertical. So since a squared is underneath the x, that would be horizontal. So we're going to count 6 units to the right, 6 units to the left, 3 units up, and 3 units down. And that's going to create the ellipse. Alright, and then on the second one, what we have x squared equals y minus 3. So it's only one squared term, so we're looking at a parabola. We want to solve for the variable not being squared, so we're going to add the 3 to the other side and get x squared plus 3. And that's actually in the correct form. I'll go ahead and write so you can kind of see the 0 there. But we didn't have to complete the square. So now we're left with a vertex at x equals 0, 3. And there could be some other information, but we know it's going to be vertical because it's y equals, and it opens up. So at 0, 3, that intersects right here, and then we know it's going to open up. Now this isn't going to be a perfect graph. I don't need it to be for what we're trying to do. We're just trying to find where they intersect at. So based on that, we can see that they intersect at the point 0, 3. So if we plug that point back into either one of those equations, it should give us a true statement. So our final answer is the solution to the system is at 0, 3. And that's how we're going to solve the systems that we're going to be dealing with. But we're probably not going to do them by graphing. Let's try to do them by using algebra. So let's look at the next example here, and let's talk about how we want to do this. In most cases, we're probably going to use elimination. If you take a look at these two equations and you're kind of paying attention to what's going on here, hopefully that you recognize that there's a positive y squared and a negative y squared. So if we add these two equations together, it will eliminate the y squared. So let's go ahead and do that. I'm going to move the 16 to the other side because the 30 is on the other side. So we have 5x squared plus y squared equals 30, and then 9x squared minus y squared equals negative 16. And if we add the two equations, we get 14x squared is equal to 14. And so normally when we were doing this with linear, we would solve and we would get one answer. But we're going to get a lot of different possibilities here because we're dealing with quadratics. So we divide by 14 and we get x squared equals 1. Well, when we take the square root of both sides, we get x equals plus or minus 1. So there's two possibilities for x. What happens when x equals negative 1, and what happens when x equals 1. And we got to solve for both of them. So once you solve using elimination, you get one of the variables and then have to plug it back in to get the next. So we're going to plug it back into the first one. So we'll do 5 times negative 1 squared plus y squared equals 30. And so negative 1 squared is 1, so this will be 5 plus y squared equals 30. Y squared equals 25, so y is equal to plus or minus 5. So there's actually, for that one input value, there's two outputs. So that gives us two ordered pairs. Same thing when we go to plug x equals 1 in. We get 5 times 1 squared plus y squared equals 30. And then we get 5 plus y squared equals 30 because you're squaring the 1, so you're going to get the same thing. Y squared equals 25, and y is equal to plus or minus 5. So what are our solutions? Well, we got a couple here. We got when x is negative 1, y is negative 5. When x is negative 1, y is positive 5. And then we also have when x is 1, y is negative 5, and when x is 1, y is positive 5. So there's actually 4 places that they intersect. And if you think about this, I'm not saying this is exactly what this looks like, but this is an ellipse, and this one down here is a hyperbola. So can you have an ellipse and a hyperbola that intersect 4 times? Absolutely. So so you can get up to a possible 4 solutions on these. Alright, let's go ahead and do one more. Once again, you might want to pause this video at this point and try this one on your own. Once again, as I'm looking, I noticed that the y squareds are equivalent, so we can once again add those to eliminate. I am going to maybe get everything on one side before I go and do this, so I'm going to rewrite the bottom one. I'll leave the top one the same. And then this one I'll change to x squared minus y squared, and I'm going to subtract the 9, kind of line everything up here. So when I add x squared plus x squared is 2x squared, the y's cancel, minus 16x, that just carries down, and then what looks to be plus 30. And so we're left with a quadratic, and we just need to solve the quadratic. I would take a 2 out, make it easier. And I'd always try to factor first if I can. On this one it looks like we're good. We can do x minus 5, x minus 3. And once again we get 2 possible solutions for the system with our x values. So I'll go up here again and we'll do x equals 5, and then we'll turn around and do x equals 3. I'm going to plug it into the second equation. It looks a little bit easier on this one. So we got 5 squared minus y squared equals 9. That's 25 minus y squared equals 9. Subtract the 9, and that'll be 16 equals y squared. and then you take the square root, and once again you get two possible solutions from there. So then what happens? Well, let's go ahead and do it. X equals 3. So now we have 3 squared minus y squared equals 9, and we get y squared equals 0. And when you go to take the square root, normally we'd get plus or minus 0, but 0 obviously is just 0. And so now on this one, it looks like we're actually going to get 3 solutions. We got 5, negative 4. We have 5, positive 4. And then on this one over here, we got x equals 3 and y is 0. So we got 3 solutions on this one. And this one is a circle and a hyperbola. So to kind of think about how you can get a circle and a hyperbola to have 3 solutions. Once again, I'm not saying this is what it looks like, but it could be something like that, where it hits twice on that side and only once on the other. Just a possibility there. So that's how you solve systems of quadratics. There's a lot of different variations, so please make sure you look at the homework on this. Like I said, most of this stuff that you're going to be doing is going to be solving using elimination, maybe a little bit of substitution. You'll probably be doing it all using algebra though. So here is your homework for this section. Thanks.